In problem 17, we're given the graph of the quadratic equation y equals ax squared. A is the leading coefficient. Remember, the leading coefficient determines whether our quadratic opens upward or downward and how wide it is. They have us multiply the a value, that leading coefficient, by -1/2 and ask what happens to the equation. We multiply by 1/2, which makes the leading coefficient smaller. It's half of what it was. When the leading coefficient becomes smaller, the graph becomes wider. We're also multiplying by a negative number. When the leading coefficient becomes negative, it means that the graph opens downward. And so our new graph is going to look something like this. It's going to open downward and be a bit wider. Which choice represents this? Read through the choices carefully, and we see that choice 1 is correct. The new graph is wider and opens downward. In problem 18, we're asked to find the zeros of the function f of x equals x plus 2 squared minus 25. You might recognize this as a quadratic function written in vertex form, and there are several ways we can identify the zeros of this function. Let's take a look at these ways. The first option is to use inverse operations. We have zeros when the equation equals 0, so we take the equation and we set it equal to 0. Now, we want to get the item squared alone, so let's isolate the x plus 2 squared. Begin by adding 25 to each side of the equation, and now we have 25 equals x plus 2 all squared. The inverse of squared is taking the square root. Don't forget the plus and minus in front of the square root of 25. Now, we subtract 2 from each side, and we're left with -2 plus or minus 5 is equal to x. Solve each of those equations, -2 plus 5 and -2 minus 5. X equals 3 and x equals -7. So the zeros of this function are -7 and 3, choice 4. Another option would be to look at the factored form of the equation. We can do that by multiplying out the x plus 2 squared, combining like terms, and then factoring. When we factor, we have f of x equals x plus 7 and x minus 3. The factors reveal the zeros. Take each factor and set it equal to 0. Solve, x equals -7 and x equals 3. Again, choice 4. A third option is to graph the function and find the zeros. You can graph this using your graphing calculator. When I graph it, I see that I have a 0 at -7, 0, and at 3, 0. Zeros are where the function crosses through the x-axis. Once again, -7 and 3 are the zeros of the function. One last option I have is to identify the zeros in a table. Graph the function and pull up the table of values on your graphing calculator. Look for where the output is 0. At -7, we have an output of 0. And when x is 3, we also have an output of 0. That means that the zeros of the function are at x equals -7 and x equals 3. In exercise 19, we're told that we have 2 football players, McGee and Fitzpatrick. We're told some information about each of the players' salaries, and we're asked which system of equation could be used to determine the amount that each player earned in millions of dollars. Let's organize the information. We're told that McGee's earnings were $0.005 million more than those of Fitzpatrick's. We're also told that the 2 players earned a total of $3.95 million. F represents Fitzpatrick's earnings, and M represents McGee's earnings. The first statement we have is that together they earned $3.95 million. Fitzpatrick's earnings plus McGee's earnings equals 3.95. There's our first equation. The second piece of information we're told is that McGee's earnings were $0.005 million more than Fitzpatrick's. McGee equals Fitzpatrick's plus $0.005. Look at the choices carefully and determine which one is equivalent to the equations that we wrote. We see that choice 4 is that system. In problem number 20, we're asked what is the value of x in the given equation. What value makes the equation true? Remember, that's what it means for something to be a solution. We can determine which value of x makes the equation true by using substitution. Substitute each of the values in 4, 6, 8, and 11 and see which resulting equation is true. When we do that, we see that choice 1 is true, 5/6 equals 5/6. And so choice 1, 4, is the value of x that makes the equation true. In problem 21, we're given a table of values that shows the grams of carbohydrates and the number of calories. We're asked which equation best represents the line of best fit for this set of data. We begin by doing a linear regression. Enter the data into your table in the list and spreadsheet. Then go to the Data and Statistics screen and perform a linear regression. Which equation best matches that? Choice 4. That's the equation that can be used to predict the number of calories in a food given the number of carbohydrates. If you need to refresh how to perform a linear regression, go back and look in your algebra handbook. All of the steps are included. In problem 22, we're given the graph of a piecewise function, and we're asked to determine which function represents the graph. We can do this a couple of different ways. The first way is to use our graphing calculator. Start a new document and create a graph. Insert a piecewise function by pushing the button that's between the 9 and the book. Select the piecewise function option. How many pieces does each function have? Each function has 2 pieces. Enter the equation and then look at the graph. Do this for each of the choices. Carefully compare the choices along with the graph that was given to you. On careful inspection, we see that the graph in choice 2 matches, which means choice 2 is the answer. We could also do this by visually inspecting the graph. Notice that for the first piece of each of the functions, they're the same. F of x is x squared when x is less than 1. And so this isn't as much of a concern to me. The difference is in the linear piece. Let's take a look at the graph more carefully. Notice on the graph, if we were to extend the line, we can see first of all that we have a slope of 1/2 and that we have a y-intercept that's positive. The y-intercept on choice 1, 3, and 4 is negative, and so it can't possibly be choice 1, 3, or 4, leaving only choice 2. Also, notice the slope of the line is 1/2, and the only linear piece in the functions that have a slope of 1/2 is choice 2. Choice 2 is our answer. In problem 23, we're given a function that represents the height of an object from the ground after it's dropped. We're asked to determine a realistic domain for the function. Let's begin by taking a look at the graph. You might recognize it as a quadratic function, and when you create your graph, you may have to zoom out so that you can see the whole thing. Let's take a look at the different pieces of this graph. First of all, the lower axis, the x-axis, represents the amount of time in seconds after the object was dropped. The y-axis represents the height of the object in feet. Domain is our x values. And let's look at each part of the graph. Let's begin on the left-hand side. In the shaded area, those time values are negative. It doesn't make sense to have negative amounts of time. That would be before the object was dropped. And so we can disregard that part of the domain, as it's not realistic. How about on the right-hand side? Notice right there, after 3 seconds have passed, the object hits the ground, and the graph continues. That suggests that the object went underground, which doesn't make sense either, so we can omit that part of the domain. The part of the domain that makes sense is from 0 to 3 seconds, from when the object is dropped at 0 seconds to when the object hits the ground at 3 seconds. That means a realistic domain is from 0 to 3. Choice 2. In problem 24, we're given something that looks pretty confusing, but if we look carefully, we can figure out what it means. Notice that the function has an f of n, which is an output, and f of n minus 1, which is a previous output. This equation, or function, relies on previous outputs to determine the new output. This is a recursive sequence. We're told f of 1 equals 3, that's our first term. F of n is negative 2 times the previous term plus 1. We wrote that using slightly different notation in class, but it means the same thing. In either case, we have a sequence. The first term is 3. To get the next term, negative 2 times the previous term plus 1. Negative 2 times 3 is negative 6, plus 1 is negative 5. To get the third term, we take negative 2 times the previous term, negative 2 times negative 5, and we add 1. That gives us 11. The fourth term can be found using the same formula. Negative 2 times 11 plus 1 equals negative 21. And finally, to find the fifth term, negative 2 times negative 21 plus 1 equals 43. That's our fifth term, and so choice 4 is the correct answer.